Challenger.
Welcome, viewer. This is part of the video series where I debunk flat earth proof from the channel Is Bible from Heaven? Is the Earth a Globe? Out of their 29 videos, so far we have covered 1 to 10. If you like this content, you might want to check them out in playlist. Today, the video in question is Flat Earth Proof 11, Outer Space. I will cheat a little bit. The video on outer space starts on planet Earth and talks about how gravity is not real, and ending with bubbles in ISS. Their video proof 14 is all about ISS, and as you have guessed it, there is proof 18 about gravity and buoyancy. So we will discuss it then. Taking all this out, here is what we are left with.
Flat Earth Proof 11, Outer Space. Let's just turn to investigate the vehicles of space and ask, can rockets work in a vacuum? A logically necessary question. Well, to answer, rockets require matter to push against in order to move forward.
How does spacecraft move in space if there is no air? I guess this question arises from the simple fact that some forces like sound need a medium to travel. In space, because there is no air, there is no sound. Then we follow it up with, aircraft always use air. Duh! Let it be propeller engine or jet turbine. Design of the wing causes the airflow to generate an upward force called lift, which allows it to fly. So, spacecraft can never travel in space. QED. Well, is it really? Let's say it the following way, and we can all then agree. A craft designed to use air for movement cannot travel in space. That's better. But a spacecraft does not behave the same way as an aircraft. For actual reason, we have to look at our old friend Newton's third law of motion. Every action has an equal and opposite reaction. The beauty is in the simplicity itself. When I learned it as a little boy, we were given the example of sitting down on our bench. We are sitting down and exerting a downward force on the bench, and the bench is exerting an equal and opposite force. When this opposite force is no longer equal, the bench would break and we would fall on our arse. Engine in space behaves as expected by this law. When a rocket shoots fuel out of one end, this propels the rocket forward. As you can see, no air is required for that. This principle can be observed on Earth as well. NASA provides an example of you standing on a skateboard and throwing a bowling ball forward. That force would push you and your skateboard backward. One remaining question. How does the fuel burn in space? Well, simply because we take the required oxygen ourselves in form of liquid oxygen.
Now, consider during Apollo 17 how the astronauts were able to capture the blue marble image at only a tenth of the distance to the moon. This is akin to taking a picture of the runway from an airplane shortly after takeoff. This fact alone raises suspicions.
This is such a horrible analogy, even worse than all of mine. Bunch of issues here, and this is a non sequitur itself. Let's start on my driveway. On one end, I have my beans and protected woods. Then around 30 feet of path leading to the main road. This is my point. I start from my bin and walk 3 feet towards the road, or 1/10 the distance. Then with my camera, depending on the lens angle, I may or may not be able to get the full bin into view. I might have to walk further just a bit more. The point I'm making is, all these distances are not related. When we're talking about something fitting inside a frame, there are only 3 things we need to worry about. and we can calculate the third value from the other two. First, dimension of the object in question. Second, distance between camera position and object. And third, viewing angle or lens angle. Note, I am ignoring other variables. Aspect ratio we will cheat. For this demonstration, we are talking about small distances, so refraction and such wouldn't really matter. And lens focal length are measured differently, but we can use standard degree instead of a f value. Cheating with aspect ratio, let's use a square sensor to simplify. So if my beam is 3 feet tall and it is taller than wider, and I'm standing 3 feet away, what viewing angle do I need to fit that whole beam in photo? This is simple trigonometry, where we can draw two right-hand triangle, where adjacent leg is the distance, opposite leg is half of the height of my beam, and finally, viewing angle is double of adjacent angle. Tangent of adjacent angle is opposite divided by adjacent. With adjacent of 3, opposite of 1.5, we get adjacent angle of 26.565 degree, which means our viewing angle needs to be a little more than 53 degree. As you can see, the distance between the beam and the road is not in question here. Let's try the values for blue marble. The distance is our adjacent. Here we have a problem. I don't know what the ratio of earth was in compared to the whole photo. I'm pretty sure I should be looking at the photo AS17 148 22727. Visually it looks like a little less than 50%, but I feel that is a bad way to test. A better way to maybe calculate the opposite from photo, but we need the viewing angle. Well, Dr. Harrison took the picture with a modified Hasselblad 500 EL, a Zeiss planar 80mm f2.8 lens, and a fixed shutter speed of 1 to 50th of a second. Damn, what I wouldn't do for a Hasselblad. I will admit this is a lot less fun than I had expected. Maybe my searches were wrong, but I couldn't find an actual angle. Oh, don't get me wrong. Wiki has a page with bunch of values, but those are for 35mm camera. So I need to calculate it myself. Which brings me to the word modified Hasselblad, and that's all she wrote. So I have to make some assumptions. 70mm film that was used is a wide high-resolution film gauge for motion picture photography. The film is 65mm wide. The standard aspect ratio is 2.2 to 1. Now there are some lenses that had an ultra-wide 2.76 to 1 aspect ratio. Finally, due to aspect ratio, there are 3 measurable viewing angles: horizontal, vertical, and diagonal. I really wanted to use vertical, but with the difference in lens ratio, and though I'm almost sure that Zeiss had a standard ratio, let's stick with horizontal. At infinity focus, horizontal angle would be 2 times arctan of h divided by 2f, where h is our film width and f as focal length of lens. So in our case, it is 2 times arctan of 65 divided by 2 times 80, which becomes 2 times arctan of 0.40625, or finally 44.22 degree. Hopefully the math checks out. That image was taken from about 29,000 kilometers. Now what is the horizontal distance the photo would capture if the viewing angle was 44.22 degree? Opposite is tangent of adjacent angle divided by adjacent. Adjacent angle is half of viewing angle, and captured horizontal distance is double of opposite. So, opposite is tangent of 22.11 times 29,000, which is 11,781.57. Now time that by 2 to get total horizontal coverage of 23,563 km. Earth's diameter is 12,742 km, and Earth would occupy about 54% of the viewing area horizontally. Back to the image AS17 148 22727. Full width of my downloaded version is 2400 pixels, and Earth occupies about 1243 pixels. That's about 51.8% of viewing area. I am not claiming that image is not cropped. I frankly do not know. But using pure math, we can estimate how much it should occupy, and that it is perfectly feasible to take photo of the Earth from 1/10 the distance from Moon. Final nail for their coffin? Let's just play with the takeoff picture. If you're truly being honest, you guys should at least show a picture from 3,500 feet above ground. As commercial flights' typical cruising altitude is around 35,000 feet. I couldn't find a photo at 3,500, but I did find photos from 3,000 feet above ground. Do you see any difference?
But becomes even more apparent when one realizes that NASA only releases rear-facing footage from their rockets and never forward-facing footage.
Finally, the dumbest argument of all the footage are rear-facing. If there was a front-facing, then the argument would have been, why is there no side-facing footage? Given that, it would be, why is there no footage at 42-degree angle? Now I am no rocket scientist, and I will just make some observable comments. Have you ever been in a car where the rain is hitting the front windscreen so hard that you have to have your wiper at full speed, and yet the visibility is horribly low? We get that kind of weather once in a while in UK. At that time, if you look at your back windscreen, you would see a different view. The visibility would still be poor due to the downpour, but the screen itself? My car doesn't even have a back windscreen wiper. Guess why that is? Then there is the fact of when entering the atmosphere, this is truly scary. The craft is traveling very fast. In fact, so fast that the air molecules simply can't get out of the way fast enough, and in a sense starts piling up in front. As the air gets compressed, it gets hot. This process is known as adiabatic heating. In fact, it gets so hot that it starts to glow. We call it incandescence. This happens around 525 degrees centigrade. In some cases, the air gets so hot that the molecules start to dissociate and literally breaks down into ions and electrons. At this point, the air becomes plasma. As soon as the air molecule leaves the superheated area in front, they recombine at the back, giving off energy in form of visible light. This temperature can reach to about 1,649 degrees Celsius. So, is it possible that due to this immense temperature, don't shake your head, I'm not done yet. Wait till you hear the whole thing so you can understand this. Now, the engineers deemed it more necessary to protect the lives inside instead of having the demand of flat earthers in forefront of their mind. This is where I'll end this video. Thank you for watching. If you have enjoyed this content so far, please drop a like and comment, and maybe even subscribe to know of my latest uploads debunking the rest. That would be greatly appreciated and would help my small channel grow. Have a safe day. Signing off.